Hi guys, let's go over interpreting a box plot. I'm just going to quickly put the annual snow depth thing back in. So interpreting a box plot is slightly different to what we've gone over before. It's trying to understand what the data set is going to look like based on what we've seen. So interpreting a box plot. Well, what you need to do is first look at your median and ask is it centered? And in our case, what? No. And in our case, I would say that it is, right? It's roughly, the distance here is roughly equal to the distance here. So it's in the center. The other thing is, are either the tails of the box plot, are the tails of the box plot particularly different in size? Well, again, I would say no, this is approximately the same size as this. And the normal distribution we would choose to draw by this, we would assume that the data set looks something like this. Oh, jeez, that's terrible. Oh my god. Yeah, whatever. Approximately normal, right? So the distance there is the same as the distance there, and the proportion here is the same as the proportion here. So you would know that these encompass the same percentages. Well, now let's look at an example of something that is not normally distributed. Is not that it's not normally distributed, it's skewed data. So I'm going to go over this with the eraser. Well, what do we have here? Well, I would say in this case that the median is not centered this time. That it is not in the center. Why do I say that? Well, it's because the distance between Q1 and the median and Q3 and the median is quite significantly different. You can see that Q1 to the median is much larger than Q3 to the median. The other thing to note is that these tails are of much different size. So what does this mean? Well, if we were to draw a normal distribution, we would see that it is skewed. Now, which way is it skewed? Well, there are more values in a range over here, so it is skewed to the left. So a normal distribution might look something like this. And what you notice is that this distance here is far different from this distance, and this proportion is different to this proportion. These don't encompass the same area. Now, why is that? Well, it's because the values on this side. Oh, sorry, let me do another color real quick. I'll do pink this time. Purple. I like purple. Purple's my favorite color. Well, the values on this side, these values are spread over a far larger range than the values of this side, as you can see by the size of these little brackets that I've done. With these little, what do they look like? Like mountain ranges, I guess? Either way, you can see that the range is much larger, and as such, you want to represent a larger range on this side, which we do, compared to a range on this side. Not quite as large. So this goes to show the variability on the data is one-sided. That the bottom half of the data shows a larger variability than the top half of the data, or rather the 50th percentile and lower values show much larger variability than the 50th percentile and higher values. And that's really what we're trying to get across with the interpreting a box plot. Now, there's one other thing. I'm just going to hopefully be able to paste this again. Sweet. There's one other thing that I wanted to go over, which I kind of forgot to in the previous box plot thing we did. So let's go over two new things. We want to have here. We have interquartile. Oh no! Why are you doing this to me? We have our interquartile range. Interquartile range. Maybe you can guess what this is while I'm writing the next one. And we have our range. Well, interquartile range. Our interquartile range refers to the range of value, what is the value of Q3 minus Q1? Well, I believe we said that Q3 was equal to 105, and Q1 was equal to, what was it? Did we say 50? 52, I think? Well, our interquartile range, the value that is equal to the distance between Q1 and Q3, is equal to 53. And our range, well, that's just the minimum minus the maximum. It's the same thing, but over a larger scale. So here's our max, and here's our minimum, and it's just the value difference that we see here. So in this case, I believe we said it was like 125, was it? Something like that? Minus 30. Well, our range is going to be equal to 95. Look at that. So these are two other values that we can use to look at information in the box plot. Sorry for not mentioning it in the previous video.